Hello everyone, today we are going through increasing and decreasing functions, second application of derivatives, increasing and decreasing functions. Here we will learn how to determine if the function is increasing or decreasing. So now let's discuss, let's understand the concept of increasing and decreasing function with examples, okay. So here let's take a function f of x is equal to x plus 4. F of x is equal to x plus 4. And here let's take its domain is R, okay, set of real numbers. Now when x is equal to 1, what is the value of f of x? That means f of 1. F of 1 is nothing but 5, right? When x is equal to 2, f of x is equal to f of 2, that is 2 plus 4 is 6. When x is equal to 3, f of x is equal to f of 3, that is 3 plus 4, 7, right? When x is equal to 4, f of x is equal to f of 4, that is equal to 8. Okay, now let's take negative values, okay? Negative integers, that is when x is equal to minus 4, f of minus 4, that is equal to 0. When x is equal to minus 3, f of minus 3, that is f of x, okay? Minus 3 plus 4, 1. When x is equal to minus 2, f of minus 2 is 2. When x is equal to minus 1, f of minus 1 is 3, right? See, here when x increases, okay, when the values of x increases, f of x increases, right? Here the values of f of x, values of the function increases as x increases, okay. Such a function is called increasing function, okay. When f of x, see, if f of x increases as values of x increases, then that function f of x is an increasing function. See here also, here when x increases, right, as x increases, f of x increases, right. See, minus 4, minus 3, minus 2, minus 1, it is increasing, right. So here also the f of x, values of f of x is increasing, right. So such a function is called increasing function. So here we can say this function f of x is equal to x plus 4 is an increasing function on R, okay. And let's take another function, f of x is equal to minus x. F of x is equal to minus x. See here, when x is equal to 1, here what is f of x? That is f of 1, that is equal to minus 1, right? When x is equal to 2, what is f of x? F of x is equal to f of 2, that is equal to minus 2, right? When x is equal to 3, f of x is equal to f of 3, that is equal to minus 3. When x is equal to 4, f of x is equal to f of 4, that is equal to minus 4. See, here when as x increases, f of x decreases, right? Minus 1, minus 2, minus 3, minus 4. That means it is decreasing, right? So as x increases, f of x decreases. So such a function is called decreasing function. So here f of x is equal to minus x is a decreasing function, okay. Here f of x is equal to x plus 4 is an increasing function. F of x is equal to minus x is decreasing function. Now I hope you understood what is the concept of increasing and decreasing functions. Now let's understand this with graph, okay. I have taken an example, f of x is equal to square root of x. Here x is greater than or equal to 0 because square root of minus number, it will be a complex number, right. So here let's take x is equal to 0. When x is equal to 0, what is the square root of 0? 0 itself, right. So the point is here, okay. When x is equal to 1, its square root of 1 is 1 itself, right. So here, then square root of 2 just greater than 1, right. So 1 point something. Next, square root of 3, that is root 3 is always greater than root 2, right? That is 1 point something, but it is greater than root 2. So it must be, okay, somewhere here. Then square root of 4, that is 2, square root of 5 greater than 2. So here we notice that as x increases, f of x is increasing, right? See, the graph is like increasing, right? So here also we can say this function f of x, using this graph we can say f of x is equal to root x is an increasing function. As x increases, the values of the function f of x increases. Okay, next let us take, I have taken another example, function f of x is equal to minus 2x. So here, okay, let's substitute the values one by one. When x is equal to 0, minus 2 into 0, 0 itself, okay. And when x is equal to 1, f of x, that is y is equal to minus 2. When x is equal to 2, f of x is equal to minus 4. When x is equal to 3, f of x is equal to minus 6, right? Okay. Now let's join it. See, the graph is like this. That means here the function is decreasing, right? It is going down, right? That is, as x decreases, as x increases. See, when x is equal to 1, x is equal to 2, x is equal to 3, x is equal to 4. See, when x is equal to 1, f of x is equal to minus 2. F of x is equal to minus 4, right? So as x increases, f of x decreasing, okay? So here by the graph we can say here f of x, the given function is decreasing function, okay? So here see, as x increases, f of x decreases, right? Now let's go through definition of increasing and decreasing functions. Let I be an open interval contained in the domain of real valued functions f, then f is said to be increasing function if x1 less than x2, that implies f of x1 less than or equal to f of x2 for all x1, x2 must be in the interval I. Okay, see here, if the function f is said to be increasing function if x1 less than x2, that implies f of x1 less than or equal to f of x2. See, what does it mean? Here, as x increases, that is x1 less than x2 less than x3 less than x4. So we should get f of x1 less than f of x2 less than f of x3 less than f of x4. Okay, so that means as x increases, f of x must be increased. Okay, as x increases, that implies f of x increases. So then we say this function is increasing. See here, f of x1 less than or equal to f of x2. See, for some different values of x, we will get a value of the function same values. That means, see, let's suppose we have got x2 when x2 is equal to 1. So here f of x2 we should get we will get any number, that is, okay, let's consider it is 4. And let's take x4. x4 is equal to 3. Okay, now here f of x4, that is equal to 4. Okay, sometimes we will get the value of the function same. So in that case we say f of x1 less than or equal to f of x2. In that case we say that function is increasing, only increasing function. Otherwise, see, if we get only the increasing values, okay, with the no same values, then that case we say the function is strictly increasing. Okay, that is, as x increases, f of x increases with no same values, then we say the function is strictly increasing. That is, the function f is said to be strictly increasing if x1 less than x2, that implies f of x1 less than, no equal, okay, less than f of x2. For all x1, x2 belongs to I. Okay, understood? That is difference between increasing and strictly increasing. Here, x1 less than x2, that implies f of x1 less than or equal to f of x2. As x increases, that means as x increases, f of x, values of f of x increases. But see, for some values, okay, for some values of the function may be equal. Okay, in that case, the function is only increasing. Here, for every values of x, here the function f of x different values and it increases. As x increases, f of x increases. Okay, there is no same values. Okay, value of the function. So here, when x1 less than x2, if x1 less than x2, that implies f of x1 less than f of x2, then the function f is said to be strictly increasing. Okay. Next, decreasing. F is said to be decreasing function if x1 less than x2, that implies f of x1 greater than or equal to f of x2. For all x1, x2 belongs to I. Decreasing function means, see, with examples we have already explained. Here, decreasing function, f is said to be decreasing function as x increases, f of x decreases. Okay, as x increases, f of x decreases, and here for some values of x, the value of the function may be equal. Okay, in that case we say the function is only decreasing function. Otherwise it is strictly decreasing. Okay, strictly decreasing. So f is said to be strictly decreasing if x1 less than x2, that implies f of x1 greater than, only greater than, no equal, f of x1 greater than f of x2 for all x1, x2 belongs to I. Okay, f is said to be strictly decreasing if as x increases, f of x decreases, there is no value of, no same value in f of x. Okay, as x increases, f of x decreases. Okay, so that is, then function f is said to be strictly decreasing. Okay, now let's study how to determine the given function is increasing and decreasing function using derivatives. Our chapter is nothing but applications of derivatives, right? So here, using derivatives, how to find the increasing and decreasing function? What are the rules to find increasing and decreasing function? So for that, we have to take, let f of x be a function, continuous function, f of x be a continuous function on closed interval AB and differentiable on open interval AB, then f is, that is f of x is increasing, f of x is increasing if f dash of x greater than 0 for all x belongs to open interval AB. Okay. See here, suppose you are asked to check the whether the given function is increasing or decreasing. See, you have to find the f dash of x, derivative of given function. If the derivative of the given function greater than 0, okay, greater than 0, then the function is increasing function. Okay, the given function is increasing function. That is, f of x is increasing if f dash of x greater than 0 for all x belongs to open interval AB. Then next, f of x is decreasing if f dash of x less than 0 for all x belongs to open interval a. Okay, if derivative of the given function is less than 0, if it is negative or less than 0, then the given function is decreasing function. Okay, now let's go through some examples. First example, show that the function x cube minus 6x square plus 15x plus 4 is strictly increasing in R. Very important question, 2010-2013 question. So here the given function is f of x is equal to x cube minus 6x square plus 15x plus 4. So what are the rules to find increasing and decreasing function? So here we know that if f dash of x greater than 0, here strictly increasing, right? So for strictly increasing, we should get f dash of x greater than 0. If f dash of x greater than 0, then we say the given function is strictly increasing. Okay, so for that, first of all, we need to find f dash of x. F dash of x. So what is f dash of x? Derivative of f of x with respect to x, right? So f dash of x is derivative of x cube is 3x square minus derivative of 6x square is 6 into 2x, right? That is 12x. Derivative of 15x is 15. Derivative of 4 is 0. Okay. Now, how to check whether this greater than 0 or less than 0? Here, we have to simplify. Okay. For that, we have to simplify, and actually, we should try to simplify in the form of get in the form of x plus a whole square. Okay, why? Because we know that the square of any number, any real numbers, that is always positive, right? So we are trying to simplify to get in the form of x plus a whole square. Okay, so let's try. Here 3 is common, right? So let's take 3 outside. 3 into x square minus 4x plus 5. Okay, we have taken 3 outside. Then how can we write this? 3 into here x square minus 4x plus 4 plus 1. Right? Now here see we can write these terms, these 3 terms. See, it is in the form x square. We can write, see, minus 2x, 2 into x plus 2 square, right? That is nothing but x minus 2 whole square, right? See, it is nothing but x minus 2 whole square. So we can write 3 into x minus 2 whole square plus 1. Okay, that is, let's take 3 inside. Okay, 3 into x minus 2 whole square plus 3. See here, it is always positive, right? It is always positive. That is the square of any expression, square of any number, that is always positive. So if it is positive, into 3, it is a positive, right? Plus 3. So into 3 is always positive. Plus 3 is always positive, right? So when adding 3 to any positive number, it will be positive. And here, see, if x is equal to 0, it is, if x is equal to 0 also, see, we will get positive numbers only. So here we will not get any 0, right? If x is equal to 2, if x is equal to 2, we will get this term 0, but f dash of x is always greater than 0 because 3 is here. Okay, just think here. See, here we will not get any 0, right? Because see, if x is equal to 2, we will get this term 0, but f dash of x is equal to 3. Okay, therefore this f dash of x is greater than 0. Okay, because this term x minus 2 whole square is always positive. Positive into 3 is always positive, plus a positive number, that is always positive. And if it is 0, then also f dash of x is greater than 0. Okay, so here we have got f dash of x greater than 0. Therefore, by derivative test, we say the given function f of x is equal to x cube minus 6x square plus 15x plus 4 is increasing in R. Okay, because if any values of x, if positive values, negative values, any integers, any rational numbers, here we will get f dash of x always greater than 0. Okay. Okay, now let's understand in which interval the given function is increasing and decreasing. Okay, we know that. See, let's take example. F of x is equal to x square. Okay, it's our graph. Okay, paragraph. So here, see, we know that where x belongs to 0 to infinity, we know that as x increases, f of x increases, right? Because when x is equal to 0, f of x 0. Okay, when x is equal to 1, f of x is 1. When x is equal to 2, f of x is 4. That is, as x increases, f of x increases. Okay, but here, what about x belongs to minus infinity to 0? See, here in this case, we know that when x is equal to 0, f of x is equal to 0. Then when x is equal to minus 1, f of x is equal to, let's take some other values, increasing. Okay, when as x increases, we have to show that is f of x decreases, right? So let's take f of x is equal to minus 5. So what is f of x? 25, right? As x is equal to minus 4, when x is equal to minus 4, f of x is equal to 16, right? X is equal to minus 3, f of x is equal to 9. X is equal to minus 2, f of x is equal to 4, etc. Okay. So here, see, as x increases, f of x decreases, right? So here we say in this interval, that is open interval minus infinity to 0, the given this function x square, f of x is equal to x square is decreasing. Okay. But in this interval, the function f of x is increasing, right? Because here, suppose it is, okay, when you know, right? F of x is equal to 1, f of x is equal to 1, when x is equal to 2, f of x is equal to 4. So when as x increases, f of x increases. See here, as x increases, f of x increases. Okay, and when negative values for minus infinity to 0, so this value is here like this, decreasing. Okay, so here, so how to find the points, that is how to find the interval, in which interval given function is increasing or decreasing. So here another example, let's take f of x is equal to sin x. F of x is equal to sin x. Here, see, it is the graph of the sin x. Here we can see minus pi by 2 to minus pi to minus pi by 2, this function is decreasing, right? This function is decreasing. Okay, and here minus pi by 2 to 0, this function is increasing. Okay, and 0 to pi by 2, it is increasing, and pi by 2 to pi, it is decreasing. Okay, so for some intervals, this function is increasing and decreasing. Okay, now let's study how to find the intervals, on which intervals the given function is increasing and decreasing. Okay, now let's see the method to find the intervals in which the function is increasing and decreasing. See, let's take an example. F of x is equal to x square. Okay, so first we will find f dash of x, 2x. Okay, so here we will find the intervals in which the function is increasing and decreasing. So here f dash of x is equal to 2x, right? Then we will do, next step is f dash of x is equal to 0. That implies 2x is equal to 0. Okay, that implies x is equal to 0. This point is called the critical value. Okay, so here we have got x is equal to 0. Then next what we have to do is, here divide this domain, its domain is R, divide the domain into two open intervals, that is minus infinity to 0, 0 to infinity. Okay, then after that we will check. See, in this interval, what f dash of x is either increasing or decreasing. And in each interval, we will check the derivative of the function increasing or decreasing. Okay. So, let's take another example. See, after going through an example, you will understand it quickly. Okay. So, here f of x is equal to sin x. What is f dash of x? That is cos x, right? So next step is f dash of x is equal to 0. That implies finding the critical values, okay? So here f dash of x is equal to 0. That implies cos x is equal to 0. When cos is 0? When cos pi by 2, cos minus pi by 2 is 0, right? So x is equal to minus pi by 2 and x is equal to pi by 2. So now here divide the interval. Here suppose the interval is minus pi to pi, okay? So we divide this interval into the open intervals, okay? Here minus pi to minus pi by 2, then minus pi by 2 to pi by 2, okay? All are including in this, right? So next another interval, that is pi by 2 to pi, okay? See, minus pi to pi. So here we have to find the critical values. So after that we divide the domain into open intervals in this form, okay? After that in each interval we will check the f dash of x, either increasing or decreasing, okay? Now look at an example. Find the intervals in which the function x cube minus 6x square plus 9x plus 15 is increasing. See here we have to find the intervals in which the function is increasing. See what is the method? So first of all, okay, the function, given function, we will write given function f of x is equal to x cube minus 6x square plus 9x plus 15, okay? Then we will find the derivative of the given function, that is f dash of x. F dash of x is equal to 3x square minus 12x plus 9. Derivative of 15 is 0, okay? So here, see, we have to make it in the form of, it's a polynomial, so here we have to make it in the form of x plus a into x plus b, okay? So that we can find the critical values, okay? So here 3 is common, right? So let's take 3 outside. So it will be 3 into x square minus 3 taken outside. So 12 by 3 is 4x plus 9 by 3 is 3, okay? Now how can we write this polynomial? That is in the form of x plus a into x plus b, so that we can find the critical values, okay? So here 3 into, see how can we write this? Here it is 3, so multiplication of two numbers is 3, that is 3 into 1, right? And addition is minus 4, that is minus 3 minus 1, right? So here x minus 1 into x minus 3 is, x minus 1 into x minus 3 is nothing but x square minus 4x plus 3, that is addition is minus 4, minus 1 minus 3 is minus 4, and multiplication is plus 3, minus 1 into minus 3 is plus 3, okay? So this can be written as x minus 1 into x minus 3. Next, f dash of x is equal to 0, that implies to find the critical values, okay? 3 into x minus 1 into x minus 3 is equal to 0, that implies here if we take 3 right side, it will be x minus 1 is equal to 0 or x minus 3 is equal to 0, that implies x is equal to 1 and 3, x is equal to 3. So these are the critical points. Now here we divide this domain R into the intervals using this, okay? 1 and 3. So what are the intervals? Here minus infinity to infinity, that is the domain, okay? So here minus infinity to 1, okay? Then 1 to 3, then 3 to infinity, okay? So 3 intervals we have got. So here now let's check f dash of x either increasing or decreasing in these intervals, okay? See how we will find. So here minus infinity to 1. See what is our f of x, f dash of x? Here we have to check f dash of x greater than 0 or less than 0, okay? Positive or negative. So f dash of x is 3 into x minus 1 into x minus 3. It is our f dash of x, okay? So first of all let's check about in the interval minus infinity to 1, okay? So minus infinity to 1. Okay. So f dash of x. See the points in the minus infinity to 1. We know that all the values are negative. Right? All the values are negative. Minus infinity to 1. So here 1 is not included. Right? So here 3 into, see, substitute x is equal to the values in minus infinity to 1. See, in minus infinity to 1 all the values are negative, right? See, if you substitute negative values in x, so what we will get? Minus, suppose x is equal to minus 5. So, minus 5, minus 1, minus 6. So, if you substitute any minus value in x, you will get this minus, right? Okay, you just imagine, see here, x is equal to minus 20, you will get, so sorry, yes, okay, minus infinity to 1, right? The numbers, that is negative values between minus infinity to 1. So here, if you substitute x is equal to minus 20, you will get minus 21. That is, here x minus 1, you will get minus, right? So here, this 3 is always positive, right? So positive into, it is minus. What about this one? X minus 3. That is also minus, right? If you substitute any minus value in x, you will get minus itself, right? See, suppose you substituting minus 200, you will get minus 203. So, this value also minus in all the values in between minus infinity to 1. Okay? So, here we have what? Plus into minus. That is nothing but plus, right? That means f dash of x is greater than 0. F dash of x is plus. Okay, f dash of x is positive. In which interval? In this interval, minus infinity to 1. Okay, so here we can write f dash of x greater than 0 when x belongs to minus infinity to 1. Okay, when x belongs to minus infinity to 1. Then next, okay, so here in this interval 1 to 3. Okay, so first one is always positive, right? 3 is a positive number here. Okay, then 1 to 3. See, we know that 1 to 3, the values between 1 and 3, the positive values, always positive. So if you substitute x is equal to positive, not only positive, 1 to 3, okay. See, if you substitute x is equal to 2, what you will get? 2 minus 1, 1, that is positive. And if you substitute x is equal to 3, you will get 3 minus 1, that is positive, right? 3 minus 1 is 2. So, see, any values between 1 and 3, so if you substitute in x, okay, that is if you substitute any values between 1 and 3 in x, you will get positive values. Okay, so here the second term is positive. Then what about next third term? Here x minus 3. If you substitute x is equal to 1, you will get minus 2. Right? 1 minus 3 minus 2. And see, the interval is 1 to 3. So the values only between 1 and 3 is nothing but 1, 2, 3, that is point or something. Okay. So here you just test substituting any integers. Okay. So put x is equal to 2. What you will get? 2 minus 2. 2 minus 3, that is minus. If you substitute 3, you will get 0. Right. See here open interval. Therefore we should not put 3. That is very close to 3, that is less than 3. Okay. So here if you put any values between 1 and 3, you will get it is minus. Right. So this third term is minus. Understood? That is in the interval 1 to 3. So the values 1 to 3 are positive and only 1, 2, 3 and some points are, that is 1 point something, 2 point, 1 is not included. Okay. So 1.3 or some any values. Okay. So that is, so substitute x is equal to, if you substitute x is equal to any values between 1 and 3, you will get it is negative. Okay, negative. That is, suppose if you substitute 2.5, so what you will get? 2.5 minus 3, that is minus 0.5, right? So here you will get minus value. It is plus, second term is plus, it is minus. Plus into plus, plus, plus into minus, minus. So it is minus. So that means, see, this function f dash of x is negative in the interval 1 to 3. Okay, f dash of x is less than 0 when x belongs to 1 to 3. Okay, then what about third interval, that is 3 to infinity. Here 3 is positive. Okay, then here 3 to infinity, the values in between 3 to infinity all are positive values, right? That is, all the values between 3 to infinity, 3 and infinity are positive values, right? So here when you substitute the values, positive values in x, what you will get? See, suppose it is 3 to infinity. Okay, see, all the values are greater than 3. Okay, so here if you substitute 3 or 4 minus 1, 3. Okay, so all the positive values greater than 1. Okay, if you substitute all the values greater than 1 in x, you will get positive values only here. So therefore the second term is positive in this interval. That means if you substitute any values between 3 and infinity in this x, you will get positive values. Okay, you just take some examples. See, you take 50. Okay, 3 to infinity means all the values, all the positive values greater than 3 are included, right? So here just substitute x is equal to 50, what you will get? 50 minus 1, 49. It's always positive in this interval. Okay, so here it is plus. Then what about x minus 3? See, here also it is given the interval 3 to infinity. So here the values always greater than 3 to infinity, all the positive values, and it is greater than 3. Okay, so here if you substitute 3, it will be 0, but 3 is not included and greater than 3. Okay, so substitute x is equal to 4. What you will get? 4 minus 3, that is 1, and 5 minus 3, that is 1. So that is 2 positive values, right? So if you substitute any positive values greater than 3, this term will be always positive. Okay, so this term is positive in this interval. Okay, so plus into plus into plus, that is plus. So here f dash of x is greater than 0 when x belongs to 3 to infinity. Okay, so here we have got f dash of x is greater than 0 in the interval minus infinity to 1, f dash of x is less than 0 in the interval 1 to 3, f dash of x greater than 0 in the interval 3 to infinity. Okay, now we say in which interval the function is increasing. So in which interval? See here, in minus infinity to 1 and 3 to infinity, the function is increasing. Okay, and in the interval 1 to 3, the given function is decreasing. Okay, so we can write f of x is increasing. Here we have to write only increasing, right? So increasing in the interval minus infinity to 1 and 3 to infinity. Okay, only these intervals the given function is increasing.